if I have a triangle ABC and there is a line which is parallel, let's say to AC, and this is DE. So tell me, what does the BPT tell us? What is the basic proportionality theorem tells us? If DE is parallel to AC, then what happens?
B by AD is equal to by
Okay, so I couldn't hear you, Charan, but I think you are saying BD by AD is equal to
B by
EC over
E
here.
by C, sir.
Yeah, ECC, okay, anything. So what will be the converse of this theorem? If this ratio has been given to you, if the sides are divided in the equal ratio, then the line will be parallel, right? That is what it says. So if a line divides any two sides of a triangle in the same ratio, so there is a line DE which divides two sides of the triangle in the same ratio, that is AB by DB is equal to AE by EC, then the line is parallel to the third side, which is third side is BC over here. Okay, straightforward and simple, just the converse of BPT. And this theorem you don't need to learn to prove. This is just for your understanding. Proof of this is not part of your exam, but let's learn how to do this proof anyway. Okay, this will help you to understand a few concepts. So I'm going to erase this. Let's draw the simple figure, straightforward. Let's say I have a triangle ABC. And I'm saying that there is a line DE which divides this side AB and AC into equal ratios. That is, if AD by DB is equal to AE by EC, then theorem tells us that DE should be parallel to BC. This is the statement of the theorem. So this theorem is basically converse of BPT, or we also say inverse of Thales theorem. Yeah. So what we are going to do here for as a proof is we are going to say that, okay, I know that AD by DB is equal to AE by EC, and let's say that DE is not parallel to BC. If DE is not parallel, then can we construct some line which is actually parallel to BC? So let's do that construction. Let's say so if I'm saying that DE is not parallel, then there will be some point DF or some line DF which will be parallel to BC. So if D is not parallel to BC, then we should be able to draw some line DF which is parallel to BC. Okay, so now what happens? What does the Thales theorem or the basic proportionality theorem tells? If DF is parallel, then what will happen? Use the BPT and tell me. If DF is parallel to BC, forget about DE right now, all of you.
AD by BD will be equal to AF by CF.
Yes, absolutely right. AD by BD will be AF by CF. Excellent. So, okay, but remember what is given in the question already. The question or in the proof, we already it is given that AD by DB is equal to AE by EC. So from these two, what can we understand? See, this we know that because I have drawn the by construction DF is parallel to BC. So basic proportionality theorem will give us the first equation. AD by BD should be equal to AF by CF. But in the problem, we already know that AD by BD is equal to AE by EC. Then these two should also be equal, right? So what we can say from 1 and 2, we should be able to write AF by CF is equal to AE by EC. That should happen. Okay. Now, how can we prove that E is parallel? So what idea we are going to use is, we are saying that AF by FC or CF is equal to AE by EC. So this thing is possible only when F and E coincide with each other. That means F and point E are same. Only then this kind of relation, which we have written here, this relation is possible only when E and F are same point. And if both of them are same point, by construction we know that DF is parallel, so DE also has to be parallel. Is that making any sense to you people? See, what is happening here? We said that let it not be parallel. So we have drawn it like this, but we will prove that DE cannot be away from DF. DE has to be lying on DF. Okay, only then this ratio what we have got here, AF by CF is equal to AE by EC. This is possible only when E and F are lying at the same point. That means these two are not two separate lines, but same line. Which means that since DF we had drawn it as a parallel line, it was construction. So DE also has to be parallel to BC. Tell me guys, making any sense?
Yes, sir.
Okay, so I know this is not something which you are used to of. This kind of proof you are not used to of. This is a new thing for you. So maybe you can go through the recording, try to see the proof, and then it will make more sense to you people. Okay, so don't worry about it. Just go through the recording a couple of times, listen to what I'm saying, and then it will start making sense. All right. So I will not repeat it too many times. Let's just continue. So to prove that E and F are exactly same points, what I'm going to do is I'm going to add 1 on both sides. And you will see what happens when we do that. AF by CF plus 1 is equal to AE by EC plus 1. So this is simple fraction addition subtraction. Just tell me. AF plus CF by CF. And this side, what will happen? Tell me. People should tell me.
AE plus EC
Yes, AE plus EC
by EC.
by EC. Excellent. So now look at the figure. What is AF plus CF?
AC.
Yes, AF plus CF is nothing but AC. So let's write that down. We have done this kind of thing earlier in the previous classes also, right? By adding 1, we actually make both of them equal to the bigger side, that is AC. So AF plus CF becomes AC by CF. And look at this also, AE plus EC. What is that? What is AE plus EC? E is the point over here. Is everyone able to understand that? This is the point E over here.
AC, sir.
That is also AC, okay? AE plus EC, that is also the full side AC. This becomes AC by EC. So since both of these are in numerator, can I cancel it directly here? You people will understand that. Do I need to bring it here and then cancel? No need, right? Both numerators, since this is multiplied, there is no addition subtraction happening here. Everything is multiplication or division. In that case, we can directly cancel from numerator or from both from denominator. So AC and AC will get cancelled. And I will be able to write cross multiply EC into 1. So it will become, of course, EC is equal to CF. So EC is equal to CF. How is that possible? EC and CF both are same. It's possible only when F and E, they both lying at the same point, correct? They cannot be away from each other. Is everyone able to understand that concept?
Yes, sir.
Okay, very good. What about other people? I'm saying that EC is equal to
Yes, sir.
CF. So that's possible only when F and E have to be in the same point, no? Because if F was further away, just by look at the figure what we have drawn. So if F was away from this, then doesn't it look like CF is bigger than EC? It looks like CF is bigger if it was away up over there. But if F was below this side maybe, then CF will be smaller. So both can be equal only when CF and EF, that is E and E and F exactly lie on the same point. All right, so that's it. We can just write down that this is possible only when E and F lie on the same point. Coincide means they are on the same place. They're one on top of the other. Therefore, E is parallel to BC. Because DF is parallel to BC, E and F are same point, so DF also has to be parallel to BC. Do you want me to summarize this?
Yes, sir.
Okay. Let's do a quick summary. What did we do in the problem in this theorem? What is given is AD by DB is equal to AE by EC. It was already given. AD by DB is equal to AE by EC. And what we need to prove that if this ratio is given, that means DE becomes parallel to BC. DE is parallel to BC. To prove this, what we have done, we started with the opposite assumption. Let's say that DE is not parallel to BC, just like we used to do for irrational number kind of proof, no? But this is slightly different. But the starting point is same. We assume the opposite. DE is not parallel. So if DE is not parallel, then we should be able to draw some line which is parallel to BC. So that is what we did. We have drawn DF, which is parallel to BC. And then if DF is parallel to BC, then Thales theorem or basic proportionality theorem tells us that AD by BD should be equal to AF by CF. But what was given in the question? AD by DB is equal to AE by EC. So this is already given. So you see both these left hand sides are equal, AD by BD and AD by BD or DB, whatever. So they are same. So RHS should also be same then. That is what I have written. I have taken the RHS from both and they should be equal. AF by CF should be equal to AE by EC. Confirm, give me one confirmation all of you. Are you okay up to this step?
Yes, sir.
Yes, sir.
Okay. Now, once we have this ratio, what I told you is this ratio is possible only when E and F, they have to be on the same place. This ratio is only possible in one condition. If they are at different places, then this ratio is not possible. But how to mathematically prove that? For that, we have done some simple calculation. We just added 1 on both sides. Okay. And once we added 1, the numerator became AF plus CF, which becomes AC. And we saw that on the RHS also, AE plus EC, that also becomes AC. And this AC, they get cancelled. So with that, we get EC is equal to CF. So this is a much simpler idea, right? So this we can understand that if these two are equal, then that means that EF and CF, if they are equal, that can be only possible when E and F are exactly at the same place. Otherwise, it cannot be. EF cannot be equal to, I mean to say, EC cannot be equal to EF if they are at different places. Okay. So this one. Then you just write down this concept that E and this is possible only when E and F they are coinciding. They are at the same place, which means that if DF is parallel to BC, so DE also has to be parallel to BC. Tell me, everyone is okay with this?
Yes, sir.
Okay, fine. Okay, Ryan, people, you had some test today, right?
Yes, sir.
How did you?
Yes, sir.
How did you all do?
Nice.
It was easy only, sir. Only word
Yes, sir.
problem. Yes.
Sir, ma'am gave 4 questions and we have to write only 2. Sorry,
3.
3. Sorry, sir.
Okay,
We
so
have to write only 3, sir.
okay, so for the test you wrote only 3, but I want you to complete all the 4 questions. Like, make sure that whichever you left out, that also you will practice. You try to do it in your room later. Okay.
Yes, sir.
Done,
Sir,
sir.
actually, I did by mistake 4, sir. I did not remember that ma'am told any 3.
Okay, then maybe you'll get some extra mark. Let's see.
No, sir, I did not take any photo of that, sir. I took only 3.
Okay, okay,
But in notebook, it's there, sir.
that's okay. So make sure practice those questions, and if you have doubt, you will confirm, because I have seen your question paper. All those questions I think we had discussed in class itself. Those they're same type of question. Was there anything different over there? Anyone can tell me?
No,
No,
sir.
sir.
Everything same only.
No, sir.
Same, right? Okay, fine. So get the correction done, and if there is any mistakes anywhere, then you will show it to me. We'll talk about it. Okay. Let's hope that everything all of you have done correctly. All right. So that was the proof of the second theorem, that is converse of Thales theorem or converse of BPT. Okay, so all of you have your book, right? So go to example 1 and try to solve it meanwhile instead of waiting for me. Okay, go to the example 1 from this, just after the theorem. Try to solve it on your own. I'll come there and see if you need any help. Okay, so are you people working on this question, guys? Example 1, do you need any help, or you think you can solve it on your own?
We can solve, sir.
So I hope those who are doing this already, you should be able to do this by now. Okay, you just had to add 1 and get to this stage. So let me just tell you a little bit about this example 1, what's happening here, those who need it. See, this is a very similar situation like your BPT, the theorem which we had proved. There is a triangle ABC, and there is some line which is passing from in between, and the points of intersection are D and E. They're asking us to prove that, they're asking us to prove AD by AB is equal to AE by AC. So whenever you get to prove some kind of ratio like this, first thing you should notice is whether I have to take part by part or part by whole. Did it make any sense? You see, AD is a part of the line AB. So I'm going to call it as a part from now on. AD is a part. But look at this AB denominator. It's the whole side. So there is a part by whole. Same way, of course, if LHS is part by whole, this also has to be exactly same. This part by this whole, AE by AC. Okay, but whenever some question asks you to prove this kind of a ratio, it means they are saying that you cannot directly assume it from the BPT. You have to take the BPT or basic proportionality theorem to the basic step, like this part by this part is equal to this part by this part. That means AD by BD is equal to AE by CE. That is what you can derive from the BPT. You can take it from BPT. And then in that ratio, you do some modification and you arrive at this particular ratio. That is the strategy. Okay. So what do? Given DE is parallel to BC, so by basic proportionality theorem or Thales theorem, you can write whatever you like. What happens? AD by BD is equal to AE by CE. This is what you will take from basic proportionality theorem. Don't take this one directly and say that, okay, from theorem only I will prove it. All right. Now, one more thing you need to notice. If I want to make these two parts as a whole, the basic strategy, we know that we are going to add one on both sides, right? Add one on both sides. But before you add one on both sides, you need to make sure which part you need in your proof, which is the part which we need after the whole thing addition of one. We still need this part AD. AD has to be there in the proof, in the final answer. Okay. AD and AE has to be there. So if you want this, you know that if I add one right now, what will happen? In this stage itself, let's say if I add right now, add one on both sides, what will happen? It will become AD by BD plus 1 is equal to AE by CE plus 1. And then you will do the same calculation, AD plus BD by BD. Same way, AE plus CE by CE. If you had done added one right away without doing any modifications, what will happen now? See, I have the part BD and CE, but AD has got converted to AC or AB. AD plus BD is nothing but AB. So AD got removed from the equation by adding it one over here itself. AD got removed. So remember, always the numerator gets removed. That is something which you need to remember. So if I added one here, the numerator, which is AD and AE, got removed, which is what we wanted. So this is not something which you should do. Don't add one right now. Send this AD into denominator, AE also into the denominator, and then you add one. Because we don't care about BD and CE. We need AD and AE only. Okay. So this is not something we should do. We should first do the reciprocal and send the part which we need in our final answer to the denominator, because denominator does not change when we add one. You can no need to write even reciprocal, just 2 implies that BD by AD is equal to C by AE, and in the bracket you can do reciprocals. Okay, from this, what did I do? I sent AD to the denominator, just did the reciprocal of both. All of you understand why I did the reciprocal now? Tell me.
Yes, sir.
And then after that, the steps is very simple. Just add one and get your BD converted to AB. Add one on both sides. So I can write it as BD by AD plus 1 is equal to C by AD plus 1. This will become plus AD. All of you are okay with this? Anybody needs help? Confirmation? help with any particular step, you will let me know. I'm assuming that you have understood this because you're not asking me anything. What is this PD plus AD? PD plus AD is nothing. And C plus A is nothing but AC. But what did they ask us to prove? AB should be in the denominator, AD in the numerator. So do the reciprocal once again to get the desired thing. We want AB in the denominator, AD in the numerator. So just do a reciprocal here. Implies that AD by AB is equal to AE by AC. So remember, you had to do two reciprocals in this particular question because we needed AD. So we put it in the denominator first, then we added, change the numerator to the whole, that is AB. Then finally, when we got the ratios, just did the conversion based on whatever was needed for the question. Confirmation, guys, do you understand this?
Yes, sir.
Yes, sir.